Today, I wanted to talk a little bit about search. During our most recent migration of our public documentation, which we did from Gitbook to Hugo, we ended up choosing Meilisearch as our primary search engine for our public documentation. And that didn't just give us this really fast and great search option than we had previously, but we are actually able to open up our search a lot more than we initially figured, rather than just replacing the search that we had already. So if you go to our public documentation, you'll be able to see that our search bar actually now gives us results for resources across all of our sites. So that includes the public docs, of course, but also our community site, our API documentation, our main site, and all of our templates right alongside the normal results you had gotten before. So I wanted to take some time today to talk a little bit about what Meilisearch was and sort of our maybe case study of getting it working with our existing project and how it opened up some stuff for us that we didn't have previously. So this is my face. I am Chad Carlson. I'm a technical writer for the developer relations team here at Platform.sh. And one of our main responsibilities is maintaining our public documentation. And so that goes alongside content, obviously, but also maintaining that code base. And when I took charge of this migration, I wasn't really familiar with the space of search and search engines until that migration needed to happen. So originally we had a project that was a content directory of Markdown, and using Gitbook built up our documentation. And that was good for a little bit, but customization was a little difficult, and we really relied on a plugin system that Gitbook had that wasn't even fully supported anymore. I'm gonna make this full screen. And we wanted to move over to Hugo, this static site generator, because we thought that it would give us something a little bit faster and something that we would have a lot greater control over the whole build process of our documentation. And one of the plugins that we were using in our previous Gitbook setup was Algolia, which we use for our primary search engine. So we were sold on Hugo, but that became the question, right? Do we stick with Algolia and find either some module that somebody had created that would allow us to do the same thing in Hugo, or do we move to something like Elasticsearch? And around that time, a colleague of mine showed me some work that he had done with Meilisearch, and it looked promising. You know, it's a search engine written in Rust, and you can download it as an executable server all on its own. And when we got talking, we really saw the potential of taking our Hugo site and leveraging this feature of Hugo where you can specify a custom output format, so that instead of just generating from your templates your HTML for your final documentation, you also create your a JSON version of every single page on your site. And so we thought, okay, Meilisearch's format for how it accepts data, how it accepts the documents that you want to search when you get that server running, is fairly simple. We could probably make a custom output format using this JSON custom output that will build the index for us on each of our branches. You know, that's the whole Platform.sh thing. We have development environments that can be specific only to the new features of that environment, which for us will be newly added content or new features to our documentation. So we could conceivably come up with a solution that would build a new index for every branch, host it to a search server, and have a lot of it done for us during the normal Hugo build process. All we had to do was specify the format of the index in our templates and maybe into a few partials, and include a small React app, for example, to do the autocomplete on the doc site, and we would have solved our search. So that's a little bit about what I'm going to talk today. I'm going to start with a really simple example Hugo site, talk about how we can self-index a Hugo site like our public documentation and get it into a format so that we can post it to Meilisearch once it has self-indexed. And then we will touch on one of the cool side effects that came out of working with Meilisearch and having this really simple format of what the index needed to look like, was that we had this goal for a while of providing this multi-site, cross-site search across all of our sites. And this seemed like a great opportunity to try something out. And what you see in the public documentation is a result of Meilisearch's flexibility and the flexibility of including whatever you want in your hooks when you build a project on Platform.sh, that we were able to pretty quickly turn around not just fast new search on our documentation, but get multi-site search out there. And finally, we'll cover what some of the considerations that we had to make and little things that we had to overcome in order to actually deploy a multi-app project for a Hugo site and a Meilisearch server on Platform. So first, we start with our Hugo site. During our docs migration, this was really the whole point. We were working with Gitbook and we wanted to move to Hugo. And there's no reason that you couldn't apply Meilisearch to do something very similar with another static site generator or a framework in a different language. We're just going to use Hugo here because that's what we were working with, and it makes for a fairly straightforward example. The way Hugo works on Platform.sh can be found in our Hugo template in the Platform.sh templates organization. We define a single app container for the site, and then during the build hook, we download the version of Hugo that we want to use and build our site just by running that final Hugo executable. So Hugo expects a certain directory structure, all of your markdown inside of a content directory, you have static assets inside of a static directory, and inside of a layouts directory, you have templates within HTML files that define how you want to build the whole site from these markdown files. Or you can use a theme, which we did end up doing for our public docs. We created a theme to do that work for us. So I reused some of the backbone of that theme to make a really simple Hugo site that we're going to use for this webinar. You'll see that I have a doc subdirectory and all my files within here. And we have about 12 pages of content that I want my users to be able to search. You got a couple languages. Oh, this is actually a bad heading. This should be services, but we have a couple services. We have a couple languages and some introductory pages within the documentation. We don't have a search bar there yet, but that's what we'd like to search. So we have the site. We're going to start playing with Meilisearch and adding search to this site. So when you try and get a development server for Meilisearch, you can download from this install.meilisearch.com URL and download that executable to run that Meilisearch server locally. It's going to detect the operating system that you have and give us the version that you want. And then you can just run it from our project directory. And it will spin up a development server that we can start to play around with. So quickly, we'll see some output that we have here once we've actually started the server. And there is a note here that says that there's no master key found for the server. So without a master key set as an environment variable, we can add and modify indices to our search server as much as we want. It's completely public and it's going to be fine for our purposes starting out. But then once we move to production, we can, I've just set it something simple here as master key as test. I've exported the variable here. And the result of that generates a pair of keys that I can not just restrict the fact that people can't modify the index that I have on my search server, but it will also be something that I'm going to put on the documentation side so that at least to start off, we don't really know what we're going to do with our search yet, but we can restrict queries to our search server as only those that are coming from the search bar that are on the public documentation or on this documentation example. And that's because they have this key. I think that the only other thing that I wanted to cover on this slide is a little bit of a spoiler alert. So right now we're not going to have much organization for this Meilisearch search server. We're just kind of having it in our project directory. But where we're going with this is Platform.sh allows you to specify multiple application containers when you define your virtual cluster. So if we just had this Hugo site, we would have a configuration file, this .platform.yaml in our project root that would define a single application container. And it doesn't really need any services, but it will, have a router that will direct traffic straight to this finally built application container. Where we're going with this is we're actually going to start segregating some of our code so that we have a Hugo site in a single application container and a search server in its own search application container. So that when everything is built up to the project, we're going to require those two containers to communicate with each other to get this final thing to work. But we'll discuss a little bit more on that later. So when we finally start that Meilisearch search server, that was a mouthful, locally, we're going to get a built-in server that looks like this. When we post an index to the server, it's going to be visible inside this drop down here. This is built in with Meilisearch when you download it. It'll just be available at this localhost address. So we have posted a docs index right here, and we can see the list of all the indexes that we've posted to Meilisearch at this indexes endpoint here, and we see the docs UID right there as well. And if we're going to start making queries against the documents that are in this index, then we'll be doing it here, actually at the indexes/docs endpoint. So we have a Hugo site, say we have 12 pages on it, and we want to add certain information about every one of our pages of our Hugo site to Meilisearch, and Meilisearch actually expects a certain format when you do that for its documents. We want some JSON, which is an array, and all of our pages, which we call documents, are an object inside this array. And each of them have a few attributes that are going to be either required by Meilisearch or are going to help us when we get towards the multi-site example. So I'm showing two of the documents that we want visible from the site as an example. They both have a title attribute, a URL attribute, and a text attribute. We're going to use URL when we finally build the dropdown to actually link to the results that we get. But the title and text by default become the fields that are used by Meilisearch's algorithm to actually perform the search. It'll check for presence of whatever your query was in those fields, along with some other features like distance from top of the page, proximity when dealing with multi-word queries, and typos. And then finally, we're also going to need a document ID. This is just a unique hash for each document that's going to act as a primary key for Meilisearch when we're performing these queries. So each document has a unique one, and this is the primary key that Meilisearch is concerned with when looking through its index. Also included in here are actually some attributes that aren't required by Meilisearch, but they are going to support our multi-site implementation of this. This is what ends up being used in our public documentation. So if you see here, I'm effectively considering this index to be documents in the public documentation. I'm calling the site docs. And this will be important when we change how primary sources are displayed in our final dropdown as opposed to secondary sources. And then we're also going to have this rank attribute. And the purpose of that is if you're on the public documentation and you're searching from there, we're going to assume that you would like results from the public documentation to have greater weight than all of our other sites. Public docs has a rank of 1, and other sites like community and API docs are ranked 2, 3, 4, etc. The other results are still visible, but they aren't prioritized like docs results are. And this is the custom attribute that allows us to do that. And when we get a little bit further into the multi-site example, we'll see exactly how we update that to the Meilisearch server. Excuse me. So, all right, we have this format. We have our Hugo site. How do we get all this content now that we have this index written out, generated by our Hugo site? How do we get it so that we can actually post it? How do we generate this file so that we can actually post it? So I mentioned before, Hugo has this built-in feature called custom outputs. Normally you would generate HTML from each one of your markdown pages, but you can actually specify in your configuration, we see here outputs home in our config YAML file, that we don't just want HTML for our home page, we want a JSON format of that. But similar to whether it's a theme or specific layouts that you've given the project, you need to specify a template file to say, oh, you want a JSON output? What do you want? You have to say the same thing for HTML. It's not going to know exactly how you want to display the final page markdown to HTML. You give it a layout for the index page, and it uses that to convert it into the final HTML. And the same idea here. So at the top of this snippet, I have this template file for how I want the JSON to be output for our home page. I'm kind of cheating here. The home page is acting as like a amalgam of all of the pages that I have inside of my documentation rather than specifically just the index, but we'll see that here. So we take the number of pages of all of the pages and range through them. So this is every page in our site, and we're passing the content of each of those pages to another little shortcode. And then we're using that to build up this JSON array. And there's another snippet below here that shows a part of that partial, which gives us the attributes that I showed in the previous slide, specific from, or not specific from, it maps these attributes that Meilisearch wants and that we want to have included in our final index to variables that are either specific to that markdown file, specific to the front matter of that Hugo file, or to other variables that we've created a little bit above this. And so we can use this to range through all the pages and build this final object that I showed in the previous slide, and then output that final file when you run Hugo and build the site to the public directory in an index.json file. And then we can use that to actually post to the server. So now let's actually do that. We got the index, let's post it. Getting a little lost here, sorry. So this is a screencap that I did of this same site. This is the wrong video. In my public directory, I'm going to download the Meilisearch server, and I'm going to start it. I've got no master key set. I'm in a purely development mode, no public or private key set for doing these queries. I'm going to go to the server just to show what it looks like. You'll see I have nothing in the dropdown. There's no indexes post to it. I'm going to build the site, so it's going to take that template that I showed in the last one. We'll see in our public directory, here we go. We have our index.json in the Meilisearch format that's generated on every build. So now all we need to do is actually post it to the search server. You see that we've actually pulled the text from every single one of these documents, the text and the title, specific to all of them, so they'll be part of this search. I'm going to open another window just so I can get the Meilisearch server and my post going on at the same time. Now that I've got it started, I'm going to create an index called docs, and I've posted it to the server. And so now if I refresh this page, I have an index visible here for docs. This is what we're going to actually post this index.json to this specific index. And now that that exists, I'm going to do that. So I'm going to post to our local Meilisearch server at this 7700 port. And then I'm going to pass it that file as its data to the indexes docs documents endpoint, actually. So we're in public index.json. Now that's post. We have our successful response there. And there we go. Our search is finished up. So we got those two main pieces. We've got the index being automatically generated, and we can now post it, and we see that Meilisearch has accepted the format, and we get the results for each of our queries. So now that we have those two pieces, what are we going to want next? We need something to do the autocomplete on our main app. So what we're going to use is a small React app that Hugo can access. So Hugo has access to this static directory that actually gets included inside of the final public subdirectory when it's built. So we're going to put the React app there in static scripts, and it's going to allow us later on to automate the steps that we need to actually pull in credentials into Hugo so that it can place queries to this server. So we're going to write to a config.json file, this public API key, when we do eventually include a master key in our Meilisearch search server. And it's going to include the URL. So if you look at our public documentation, there's a little bit of intelligence here where it can detect, okay, if we're in a local setup, we're going to default to this local host and port for the location of the search URL. But if we're in a platform environment, it's going to do it at a subdomain that we set up for that second search app. And it'll be written to this file, and Hugo, the React app within Hugo, will have access to this file and will be able to use it to place queries against Meilisearch. And we'll see here that we have actually now have access with the inclusion of that React app. We can search for Go, and we get the Go page, including a short snippet of the description that was pulled in from the body of the text. And we'll see here, we can go to the Blackfire page, and it's got some resilience against typos. I type in Blackfire, it expects correctly that I wanted to go to the Blackfire page. It will not just search from titles, it'll search from the body of the text. So I see here I have this PHP and a few words automated text part of this Blackfire page, and it takes me right to that Blackfire page as well. Okay, so we've gotten pretty far. We got a local running server, Hugo, Meilisearch, and we post an index to that server and pulled it into our Hugo site. We're not going to want to keep doing these updates purely through curl. So what we can do is distill some of those commands using the Meilisearch Python library into a file that we can actually begin to run during our, in this case, we're going to run it during our post deploy hook on platform.sh. But that will not only allow us to clean this up a bit, but we can automate moving this config.json file to Hugo so that it has the credentials that it needs. But we can also customize the way our search runs on our Meilisearch app. So we see here in this snippet, after I've imported the Meilisearch Python library, I can specify what are the attributes that we saw in the local server and in the dropdown. What are the attributes that I actually want available to be displayed inside my autocomplete? I want the title, I want the text, I need the URL to link to the page. And when we get into multi-site, I want the site so that I can use it to filter out results in my actual autocomplete dropdown. Searchable attributes, this is what I actually want to be indexed by Meilisearch. This is the data that I want to be used to compare against the queries, and they can be set right here. I believe title and text are already included, but I wanted to include them here just so you could see visually how it was that we update these values. Another aspect that I can include here, which you wouldn't believe how often that this happens in the public documentation for platform, is I want to be able to set some synonyms for, let's say I want a query for roots.yaml, which isn't the title of a page, and even though it's prevalent in the main roots information for platform page, I really want somebody to be able to, if they search for roots.yaml, to automatically have that roots page be #1. And there are a number of ways that I can do that by adjusting ranking rules, what I'll go over next. But one way I can do that is to set a strict synonym for those two terms, in which case I've done it 2 ways here. So if you search for roots, you'll get any results that show up for roots.yaml. And if I search for roots.yaml, I'll get any results that are specified for roots. And I can set those right here with the synonyms key, or the synonyms variable. And the next I made in this object are these ranking rules. So we'll see here that there are a few there's a default order for the way that Meilisearch's algorithm takes the index and prioritizes the results that come in your query. So I want things to be robust to typos. I want, if somebody places 2 words in their query, I want documents that have those 2 words closer together to one another to be prioritized higher than those that have those a greater distance apart with more words in between. I want attribute to be after that, which is in these displayed and searchable attributes here above. And that's sort of the priority that's set within that algorithm. But I can modify that here as well. So when we get into multi-site, I mentioned before that we have this rank attribute that's totally customized by us because we're doing documents from multiple sites. And I have this rank key that wasn't included in the default. I can actually set that as the top priority of my ranking rules and say, more than anything, if I get a result, I want those with rank equal 1 from the public docs to be those primary results. And I'll use that as the first rule when ranking results that come out of Meilisearch. I can put all those settings together and use that same library to do everything that I just did with the command line. I start the client, I create an index using my primary key, the name of the index. I can update my synonyms, my settings, and add my documents to that server. So finally, I want to touch on multi-site search. So we have this setup where we've automated a little bit. We have attributes inside of our index that will specify the origin of the documents that we're interested in. And we can use that to rank results from a query to the way that we want to rank these results and present them in our Hugo app. But how do we get that data of these additional sites? I mean, we've gone through this process to create a set of templates that during Hugo's build will generate our index for the documentation. But how does that relate then to some of these other sites, right? We don't have that same luxury of having the content right in the same repository. So in our case, the way that we've implemented this is, for the time being, we're actually taking a list of domains. So that's our community.platform.sh, api.platform, the regular platform.sh, and our templates organization on GitHub to have their own scraper. So we're going to take this Python library called Scrapey, and we're going to use it to get each of those URLs, crawl every single page, and then parse together that same format, that same index format that we built with Hugo. And so we can do that during our build hook in our search app. And then when it comes to do the update I showed in this previous slide, it just gets included in this index dictionary and just loops through and adds each of those document sources to the index that we have on our Meilisearch server. And that's it. We output from the scraper to a single output directory that also has our index JSON from our Hugo site. We've moved that there, and we just go through each one of those files and add them, post them to the Meilisearch server. They each have a rank, so we know their priority, and that's it. We can do it that easily right there. So I have another screen cap here. We have our documentation. We have our React app. Now, because we can use the Python library to generalize some of what we've done here, we can actually place queries on all of these documents and sort them accordingly to this rank attribute that we have for each of those indices. So finally, we have this all done locally. We got a Meilisearch server, we got a Hugo site, we know how to scrape content from all the other sites that we want to be a part of the final index. So how do we deploy this thing? What assumptions have we made so far that we need to take account for when we actually deploy it on platform? So I mentioned at the beginning that what we found was kind of the best solution for the time being was leveraging the fact that we can have multiple application containers to have Hugo sit within one and our search app sit within another. So we have Hugo, that main site, all of its self-indexing, and the autocomplete app sitting in its one application container. And then in another one with its own configuration file that defines that container, we have a search server and everything involved with scraping additional sites, everything that has to do with posting to an index. We have that in its own application. So locally, it's pretty easy to go, in my search server, I need to pull the index from my Hugo site into my search subdirectory so I can actually post it to my server. Or I need to give the public API key from the search server and give it to the Hugo subdirectory so that the React app can use it and actually perform search. But once it's remote, once it's on platform, we need to figure out exactly how we want that information to be shared, because by default, these application containers aren't communicating with each other. They sit at their own subdomain and they are totally separate applications being served. So the feature that we ended up implementing in order to pull this off is, you can see here in the app YAML file that we have defined for the search server, is that we build it, we run all of our posting to that server once we've gotten the index, which I should mention actually that because we need to wait for Hugo to finish its build process in order to get that index in the first place and post it to Meilisearch, we've pushed back that posting to this post-deploy hook. And you'll see that that's why we have given write access to the data associated with the Meilisearch server in this data.ms directory at the bottom, this mount define, as well as the output directory, because we want to continue to have write access for while we're doing both the scraping and the posting. So we can have write access there. But the last one that's on the bottom there, this config mount, you'll see that the syntax is a little bit different. Its source isn't local, and it has this service key. So what this syntax is actually showing different than a writable local mount is a network storage mount. So like I said, our problem is I need to get the index from Hugo to the search server, and I need to get the credentials from the search server and give it to Hugo. And so that's what this mount, this network storage mount does. It provides a channel in which after build, when our file system is read-only, I can place files in here because it has write access, and that directory is shared between the two application containers. So in this case, Meilisearch, or the Python script that I showed you earlier, is actually writing those credentials. It's giving it the URL to the subdomain where this search server is going to sit, and the API keys so that the React app can actually communicate with it. And it's writing it to this config.json file and putting it in this config subdirectory. Now, that's where it sits for the search container. But on the Hugo side, it actually sits in a deeper subdirectory that sits within the React app. So it has access to this subdirectory. It doesn't have the same name. It's not config. It's deep within that static scripts subdirectory so that it can get those files. So once we made those changes, we've really overcome the major problem. We got them communicating the credentials, and we get the index from Hugo. The last thing that we need is we need a project-wide environment variable for this Meili master key. When we were playing around with it locally, it's not something we really needed. But we don't necessarily want to open up our search to the whole internet. So we can sit this production environment variable project-wide so that for any of our development environments, and of course our production environment, our master environment, this thing will run in production, and the only things that will be able to place queries against Meilisearch will be the search bar within the Hugo app. Now, I did have some difficulty right up into this of getting it running on this simple project, but if you go to docs.platform.sh, that is exactly how this search is working here. We have network storage between a search application and a Hugo application, and they're communicating with each other through these network storage mounts. With a project-wide environment variable for this master key, we get how the public documentation works here. And I can put in a search term and get prioritized results from the public documentation. I can place another term that's specific to, in this case, our templates index that's pulled from the GitHub API. I guess in this case, it's not actually crawled, it's parsed from the GitHub API, as well as other relevant ones from our community site and from our primary website. And that's it. I know that that was a little quick, but I really do appreciate you guys all coming out and seeing really this great thing that happened from our team of not just doing the migration, but picking a tool that gave us, I think, really, really improved search. And as a plus, when we weren't even looking to do it in the first place, it seemed like an entirely separate project, finally added this cross-site, multi-site search to our public documentation across our resources. So thank you for joining. I'd be happy to take any questions that you guys might have. I do want to make a point to say that June 19th, we're going to be having a Deploy Friday with some members of the Meilisearch team, myself, my colleague Robert Douglas, and Thomas and Erlen from Meilisearch. So if you haven't made it out for Deploy Friday yet, be sure to subscribe to our YouTube channel and come out for this one if you're interested in this topic or hearing more from the people who actually make this tool.